Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2008 Calculus BC exam, question number 5. Pretty straightforward question, except for part C. This is the only reason why it's an exclusive BC question rather than a shared question with Calc AB. The problem reads, the derivative of a function f is given by f prime of x equals x minus 3 in parentheses e to the x, for x being greater than 0, and f of 1 equals 7. So the way this question's set up, it's almost like one of those graph of f prime, except they don't give you the graph of f prime, they give you the equation of f prime, which isn't really a big deal, as long as they ask us questions that we can answer. The function f has a critical point at x equals 3. At this point, does f have a relative min, relative max, or neither? Justify your answer. Well, let's find out. Let's find out what f prime of x at 3 is. So f prime of 3. That's going to be 0. We know that because if I plug in 0 here, then we're good. Now I could do the second derivative test on this thing if I wanted to, and at some point I will have to do the second derivative on this thing, but at this point it might actually be easier if I just do a sign chart on this thing and call this thing 3. I've got x minus 3 as one of my functions, and e to the x is one of my functions. Now technically e to the x I don't even need to consider because he's always positive, so he doesn't really even do anything. X minus 3 is linear, which means before the 3 he'll be negative, and after the 3 he'll be positive, meaning we've got a final interval of minus plus. So the way we can justify that is f has a local min at x equals 3 because f prime goes minus to plus. And that would be all the justification you need to get all of your points in part A. In part B, it says, on what intervals, if any, is the graph of f both decreasing and concave up? Explain your reasoning. Okay. So I'm going to go and find the second derivative of this thing. So the second derivative is going to, in fact, I'm going to move this down just a little bit because I want to compare something here. F double prime of x is going to be a little bit of product rule in my life here. So first unchanged times derivative of the second plus second unchanged times the derivative of the first. So what I think I'm going to do is I think I'm going to go and factor out an e to the x. And that's going to leave me with an x minus 3 plus 1, giving me e to the x times x minus 2. Meaning we've got a critical number at 2 now. So I'm going to go and change colors here. And I'm going to actually draw my sign chart underneath my first sign chart here. Now, if you're doing this on a different page on the AP exam, you might want to draw both at the same time, because you're looking for two things happening at once. And I always line my sign charts up like that. And so from here, my two functions are going to be, once again, x minus 2. And actually, when I say two functions, I misspoke. I don't need to include e to the x. He's always positive. And which means I will go minus plus again. So my final intervals are going to be minus plus. So what we're looking for is we're looking for a place where f is decreasing and concave up. Well, when does that happen? Well, f is decreasing when f prime is negative. F is concave up when f double prime is positive. And so therefore, I'm looking for a place on both my sign charts at the same time when f prime is negative, but f double prime is positive. So where does that happen? I believe it happens right here where these two signs intersect each other. So it looks like it's going to be between 2 and 3. Therefore, f is both decreasing and concave up on 2 to 3. All right, let's go and take a look at part C here. We're going to find the value of f of 3. So how do I find the value of f of 3? Well, one, I'm going to need an anchor. Did they give me one? I believe they did. They told me that f of 1 is equal to 7. They said that up here. So that means I'm going to anchor my definite integral down. I'm going to say the integral from 1 to 3 of f prime of x dx, using the first fundamental theorem, I'm going to call it f of 3 minus f of 1. F of 3 is what I'm solving for. F of 1 is 7. They told us that. Which means f of 3 is going to be equal to 7 plus the integral from 1 to 3 of f prime of x dx. Well, what is f prime of x dx? Well, that's the function that we were given, right? That's that x minus 3 times e to the x dx. Well, here's what I've got. I've got two functions being multiplied, and they have no relationship to each other. This is screaming integration by parts to me. So from here, let's figure out what each piece is. I think x minus 3 would be a good u, because du would be 1 dx. dv should be e to the x, and then v makes it e to the x. Now again, I could have reversed them, and I would find out that my v would be x squared over 2 minus 3x. If you choose a dv that's wrong, you'll find quickly that the problem gets worse. So play around with it if you didn't see it off the cuff, but most of you guys are going to see this off the cuff now. So on this side, I'm going to go ahead and say, all right, well then that's going to be f of 3 is going to be 7 plus, and then my integration by parts right here. So that's u times v, so that's e to the x times x minus 3, minus the integral from 1 to 3 of v, which is going to be e to the x, du is 1 dx. And again, I'm just going to go and leave this 7 out here. I'm not going to include them until the very end. What I'll do is I'll go and integrate my last piece here, which is going to be e to the x, and he's going to be subtracted, and this is going to become e to the x times x minus 3, and I will evaluate that on 1 to 3. And again, a 7 will be hanging out on the outside of all of this stuff. So at this point, we're just plugging stuff in. So it looks like I'm going to get e cubed times 3 minus 3 minus e cubed. And then that's going to subtract from e to the 1, 1 minus 3 minus e to the 1. Now at this point, you can actually leave the problem like this if you wanted to and get full credit, because remember, we're not in the business of simplifying. But if you really wanted to simplify, you could see that this thing goes to 0, and you could see this thing becoming negative 2. So negative 2e minus e would be negative 3e. But since this negative is being subtracted, he's actually being added. And then you have a minus e cubed because nothing happened to him. And then the 7 from here would come down for the right. But again, I would actually encourage you not to do what I just did. I would leave the problem right here and let the AP graders take care of it for you. So hopefully this makes sense. Go and, as always, leave questions in the comments area, and we will see you in the next episode.